Hello everyone. Let us discuss our topic on basic principles of ANOVA. Introduction to ANOVA. ANOVA stands for Analysis of Variance. It is the statistical method used to compare means between two or more groups. ANOVA helps determine if there are significant differences between the groups being compared. Assumptions of ANOVA. The data should be normally distributed with each group. The variance between groups should be equal. The observation should be independent. One-way ANOVA. One-way ANOVA compares between two or more independent groups. It tests the null hypothesis that our group means are equal. It provides an F status and p-value to determine if there are significant differences. Two-way ANOVA. Two-way ANOVA compares means between two or more independent variables. It examines the interaction between the variables and their effects on the independent variables. It helps determine if there are significant main effects and interaction effects. Two-way ANOVA is applied to a situation in which you have two independent nominal level variables and one interval or better dependent variable. Each of the independent variables may have any number of levels or conditions. Example, treatment 1, 2, 3 or no treatment. In a two-way ANOVA, you will obtain three F ratios. One of these will tell you if your first independent variable has a significant main effect on the DV. A second will tell you if your second independent variable has a significant main effect on the DV. The third will tell you if the interaction of the two dependent variables has a significant effect on the DV. That is, if the impact of the IV depends on the level of the other. F statistic. The F statistic is a ratio between the group variability to within the group variability. It measures the extent to which the group means differ from each other. A larger F static indicates a greater likelihood or significant differences between the groups. Null hypothesis. The null hypothesis in ANOVA states that there is no significant differences between the group means. It assumes that any observed differences are due to the random choice. Rejection of the null hypothesis suggests that there are genuine differences between the groups. The null hypothesis in a two-way ANOVA are these. The population means for the DV are equal across the levels of the first factor. The population means for the DV are equal across the levels of the second factor. The effects of the first and the second factors on the DV are independent of one another. Alternative hypothesis. The alternative hypothesis in ANOVA states that there are significant differences between the group means. It suggests that the observed differences are not due to the random chance. Acceptance of the alternative hypothesis supports the presence of genuine difference. Degrees of freedom. Degrees of freedom represents the number of values that are free to vary in statistical calculations. In ANOVA, these are the two types of degrees of freedom and numerator and denominator. The numerator degree of freedom corresponds to the number of groups being compared, while the other denominator degrees of freedom corresponds to the total sample size minus the number of groups. Sum of squares. Sum of squares measures the variability within and between groups. The total sum of squares represents the total variability in the data. The sum of squares between represents the variability between the groups. The sum of squares within represents the variability within the groups. Mean square. Mean square is calculated by dividing the sum of the squares by corresponding degrees of freedom. The mean square between represents the average variability between groups. The mean square within represents the average variability within groups. Calculating F static. The F static is calculated by dividing the mean square between the mean square degree within F equals MSB divided by MSW. The resulting F value is compared to the critical value to determine if there are significant differences between groups. Effect size. Effect size measures the magnitude of the differences between the group means. It helps determine the practical significance of the findings. Common effect size measures in ANOVA include eta squared and partial eta squared. Post hoc test. Post hoc tests are conducted after ANOVA to identify which group means differed significantly. They provide more detailed comparisons between specific groups. Common post hoc test includes Toki's honesty significant difference, Boniferoi and Skiffy. Type 1 error. Error refers to rejecting the null hypothesis when it is actually true. It is also known as false positive. The significance level determines the possible probability of committing a type 1 error. Type 2 error. Type 2 error refers to the accepting the null hypothesis when it is actually false. It is also known as the false negative. The power of the statistical test measures the probability of correctly rejecting the null hypothesis when it is false. Assumptions violation. Assumptions of ANOVA assumptions may lead to the inaccurate results. If the data is not normally distributed, transformations or non-parametric test may be considered. If the variances between the groups are not equal, which ANOVA or a non-parametric alternatives may be used. Interpreting results. If the p-value is less than the significance level, the null hypothesis is rejected. This suggests that there are significant differences between group means. If the p-value is greater than alpha, the null hypothesis cannot be rejected, indicating no significant differences. Reporting ANOVA results. ANOVA results should include the F-value, degree of freedom, P-value, and effect size measures. Additionally, post-hoc test results should be reported if conducted. Clear and concise reporting helps communicate the findings accurately. We come to the conclusion of this topic. ANOVA is a powerful statistical tool for comparing means between groups. It allows for the detection of the significant differences and helps understand the relationship between variables. Understanding the basic principles of ANOVA is essential for conducting and interpreting the research.